Hello everyone, welcome back to my channel Saisha's Tech. This is Amogh Kaliwal. If you are new to my channel, please like, share, comment and subscribe my channel and press the bell icon for the latest updates. In the last few videos, we were understanding some of the concepts of statistics like central tendencies to find the mean, median and mode and so on. In today's video, we will be measuring the variation in the data. Measure of the dispersion or the variation in the data can be done using three techniques: range, variance and standard deviation. Let us understand one by one with an example. Definition of range is, it is the difference between the highest value and the lowest value in the data set. Consider an example, age of the people who are going to a birthday party. There are two parties, party 1 and party 2. Party 1 consists of data ranging from 15 to 91, means all the teenagers are going to the birthday party. Hence, the range of this is 19 minus 15, that is 4. Similarly, in a birthday party 2, we can observe there are some of the children and some of the parents with grandmother and grandfather. Hence, this party range is 55 minus 4, that is 51. If we plot these values on a diagrammatical representation, we can observe in party 1 the ages are tightly coupled, whereas in party 2 the ages are spread. This can be concluded from these two examples. From the last technique, that is range, we observed that it is susceptible to outliers. In the second example, party 2, where we understood that the people with the age 55 and 40 were providing the variation in the data. To curb that issue, we have another technique called variance. Variance, it is the measure of how far a numbers are spread from the average value. Here consider we have a data and we have mean. Now each of the data point which is present in the data, how far it is from the mean. This is what provides us the variance. Now let us understand the formulas of variance. There are two types of variance. One is sample variance and another is population variance. As we have understood in the last class, sample is the subset of population. We know sample mean is represented by x bar. So xi minus x bar, that is each point in the data set minus the mean, and we square it. Why do we square it? Because we want to remove the impact of negativity in the data. As you can observe, these values will provide us the negative values. These values will provide us the positive values when we subtract from the mean. Hence, xi minus x bar the whole square and summation of all these values and divide by the number of values present in the data set. This is how we calculate a sample variance. Sample variance is represented by S square. Similarly, population variance. The main difference between the population variance and the sample variance is average value in sample variance is represented by x bar, whereas the average value in the population is represented by mu. And the number of values which are present in the data set here is n minus 1, and here we consider n as the values. The population variance provides or is represented by sigma square. Now let us understand the sample variance and the population variance with an example. We have two data sets. One is 5, 7, 8, 9, 6, 9, which can be the heights of the people in the classroom, or it might be the age of the people in the room. Similarly, we have data set 2, which can be the age of the children in the society. As we have studied, the sample variance is represented by S square, wherein you subtract each value with its mean, square it summation of that divided by the number of elements minus 1. This can be represented by, here, to find the mean, we have to add all the values in the data set divided by the number of elements present in the data set. Here we have 5 of them, we are adding all of them, the total is 35, divided by 5 is the 7. Now the mean of the data set is 7. To calculate the variance, we have to subtract each of the elements with the mean. Here you can observe 5 minus 7, 7 minus 7, 8 minus 7, 6 minus 7 and 9 minus 7. We square off all the values to remove the negative effect, divided by the number of elements present minus 1, as it is the sample variance, which is equal to 10 by 4, and the final is 2.5. So the variance is 2.5. Similarly, if we consider the population, the mean of the population is calculated similar to that of sample. Here we add all the values in the data set divided by the number of elements present in the data set, that is 91.9. The variance is calculated on the similar basis as sample, that is, you subtract each value with the mean and square them up, summation of all the values of the squares divided by the number of values present in the data set. In sample, we subtract 1 from the data set. Here we do not subtract any number. So the variance is the summation of all the values of the squared is 130.88. There are totally 9 values in the data set and the variance is 14.5. This is how you calculate variance of sample and population. As we are squaring the values in the variance to remove the effect of negativity, we cannot quantify the value of variance. Hence, we use another metric called standard deviation to quantify the value. Let us understand the definition with an example. Standard deviation, it is the measure of how spread the values are from the mean. In simple terms, standard deviation, it is the square root of variance, that is square root of s square or square root of sigma square. As we all know, variance is x minus x bar, that is all the data points in the data set minus the mean, the whole square, divided by n minus 1. Similarly, n. Now let us consider group of people in the room who are spread from 5 to 25. So the mean of the values are addition of all the values divided by the number of elements, that is 8.25. Now the standard deviation is x minus x bar, that is all the data points in the data minus the mean of the values square, summation, that is 337.5 divided by n minus 1, that is there are totally 8 data points minus 1. As we are considering sample standard deviation, it is n minus 1, that is equal to 6.5. As we are considering age in years, the standard deviation is 6.5 years. Now what does 6.5 mean? It means that in the whole data set, or the maximum values in the data set lie between plus 1.7.8 to 14.75. That is, mean is 8.25 minus 6.5, 1.78, and 8.25 plus 6.5, that is 14.75. This is how standard deviation helps us to understand the variance in the data. If you like my video, please like, share, comment and subscribe my channel and press the bell icon for the latest updates. Thank you.